name is Alberto Marquez. In this video we will discuss more models in Arena Advanced Transfer. Particularly we will discuss transporters. We will begin with a clean area for work, and we will create an entity, and this entity we will assign in the attributes. We will assign a sequence, and it will be sequence 1. You don't need to use sequences to use transporters, but that's something I would like to demonstrate here. And then in the advanced transfer we will use a leave to go to the next station. Now I am going to use, instead of using stations, I will have to use an enter, and it's not going to be based on the route because we're going to be using transporters. So I delete that connector, and then I represent process, and then I will go to the advanced transfer leave, and I will repeat that again with enter, and I will eventually leave. I'm going to bring that already, but in between I will have a process. The correct logic is for my model to enter and then go into the process, or process to leave. And I will use one more enter, and the function for this station is just to dispose the entity. Very good. Now here we are going to do this using transporters. So the very first thing that we need to acknowledge is that in order to transport, we will have to use a transporter, and the transporter will be requested. So when we go to the leave in the creation section, what we do is the transfer out is done through requesting a transporter, and that opens other set of options. One of them is a transporter ID that we are going to use. Right now I'm just going to use the name transporter 1. Some of the other features that we have is that there is a queue for the entities to wait for the next transporter to arrive and pick them up at the leave. And the selection rules for the transporters: if you have more than one transporter in that type of transporter, there's more than one resource, then you can call them in a cyclical way, or random order, or a preferred order in case they're available, or a specific member, depending on what you want to do with the simulation. Sometimes you will need specific members, specific transporters to be called, because not all will have the same capabilities. The one with the largest distance to from where it's located now to what it is requested, or the one that is the shortest distance. Here right now I will just select the default cyclical, and I don't need to save any attribute, and I will transport. Now as I select transport, it is asking me, okay, you're going to transport to another station. That's a feature that is needed. You can, in order to be effectively transporting, you need to go to a location that is defined by the station. And this location can be pre-selected in all the cases, but but I will be using sequence for the fact that I just want to demonstrate it. Okay, so that's how I have it in this leaf. I will repeat the same process with the other leaves. I transfer out using a transporter. Everything else I leave all right. Okay, cyclical transporter 1 is going to be the same transporter that is going to move all the product around this facility. And the connection is through transport, and the next station is identified by means of the sequence in the entity. Finally, I will go to the leave. A transfer out is request a transporter. The connect type is through a transport, and we are going to identify the next station by a sequence. Now, the enter one actually is the definition of the station as well as the procedure to enter the station. So it's a combined module in which the name of the station is enter one station, but also I can identify that the transferring into this station is through a transporter, and the moment that the entity is arrived, we will free the transporter. Also, we can have a delay associated with the unloading or arriving at the station. So this unloading or arriving at the station may take some time. I will not include that any number in this model, but that's an option that you have. So as soon as we arrived, we select the transporter, and the transporter name is transporter 1. I don't need to identify a particular number because it's going to be whichever transporter brought the entity. Okay, I do the same thing for station 2. Transferring is free transporter. Transporter name is transporter 1. Finally, in the station 3 or enter 3, the transfer is free transporter with the transporter being transporter 1. Now, as you can see, I have in this model to identify 4 different locations. I have the leave 1, which has to be at the distance from the station enter 1, at a distance from the station enter 2, and a distance from the station enter 3. Why do we have to have those distances? Because it might be that the transporter is just left an entity and entered 2, and now needs to pick up an entity at leave 1. So that this distance must be specified, even though it's going to travel empty and is not going loaded with an entity. The distance must be set up. So if we have 4 different stations and we need to make pairs and naturally pairs out of 2, but we need to make combinations of 2, the total number of combinations we will have will be 6. So our distance matrix should have 6 elements that combine all the possible distance from one place to another. If we only specify one pair, say for instance from leave 1 to enter 1, that is enough to define the return. But if the distance is different going in one way to the other, then we can specify the return enter 1 to leave 1 to be of different magnitude from the leave 1 to the enter 1. So we can go to the advanced transfer and look for the distance table. Right now there is no distance defined, but we have for transporter 1 ready to define those stations. And it is proposing station 1, but I don't have anything named station 1. I don't have anything named station 2. What I do have is an enter 1 station, and I have an enter 2 station. You can expand these columns to be able to read better your options, as well as the window. So that helps a little bit. And here we specify the distance. The distance could be anything, and you specify the units. Let's say that I have 20, it could be 20 meters, 20 feet, 20 miles. As long as we are consistent, it doesn't matter. Okay, and I will add another one from station enter 2 station to enter 3, from enter 3 to enter 1, and for all those 3 I am covered. Now I need to add the ones that are associated with the first leaf, and that I am not sure. I think it should be a station 1. Let's try. From station 1 to enter 1 station. From station 1 to enter 2 station. From station 1 to enter 3 station. And that defines all the 6 different stations that we will need. And I could specify different distances here. Of course, you can enter the real values associated with the geometry of your layout. I am just typing some numbers here for the demonstration. Okay, and those are the distances. And I can close this. If I go to my set of transporters, I have transporter 1, and you can see that the velocity is 1 unit per hour. I can change that to other number, maybe 10, 20 units per hour. Again, this could be miles, it could be meters. It's all right. And it's a free path. It could be guide, or it could be other options. And let's leave it like that. The number of units, I don't want to have a struggle with the number of transporters that I have. So right now we'll just make the assumption that I have 10 of them. 10 transporters. So basically the entity should not be waiting long to get picked up for any of the stations and to take to the next station. Now we said that we are going to transfer these entities to the next stations guided by definitions on the sequence. So when we go to the sequence, we have the first sequence, sequence 1, and we are going to define the sequence. And again, we have to be careful here because the station 1 should not be part of the definition of the next station. This first station in the sequence have to be the next station in the sequence. In this case, enter 1. I will expand these columns again to improve how readable they are. All right. And from station 1, I go to enter 2 station, and from there to enter 3 station, and that's all my sequence. And the clear distinction here is that I am using transporters to guide or to travel these, to take these entities through the system, and the decision on where to take them is based on the sequence. And every time a transporter is needed, it is requested at any one of these leaves. Eventually a transporter arrives, and the moment that it arrives, then it is sent on its way to the next station. Very good. Now let's try and if there are bugs, we will fix them. Okay, looks like it compiled and we have a problem. It says that the number of the station series not valid in the range 1 through 4. So clearly we have a problem with either the sequences or the stations. Let's find where the problem is. The problem looks to be at the leave, the first leave. Let's stop the run so we can access, and let's explore. We have request transporter, and that seems to be okay. Let's go to the sequences. And the distances. The problem might be here with the station 1. It might be that there is no station 1. And I don't know what is the identification of this leave. Notice that we have here all the list of all our options at the bottom for all the leaves. And it seems a problem with the sequences. Oh, I think we never did. We assign that entity. Okay. Let's see what's the problem. Request transporter cycle station series not valid in range 1 through 4. Okay, so I guess I am going to try inserting a station for where the entity is at by deleting this connector. It will leave through this leave from the station, but I will enter into the station by means of a station node, and that will give it a location to start at. And then that's station 1. So station 1 is now defined and is where the entity is when it enters here, and it will recognize that it's in station 1. Let's take a look at the distances again. The distances show station 1, which is what we have there, and the sequence shows, doesn't say, but is not needed because it's entering the state in this station 1 without the need of the sequence. It only needs the sequence to follow in the remaining steps through the facility. So let me try again. And there you go. Now it's running. You don't see the transporters right now. You only see the entities, but the transporters are going back and forth picking up entities. We can make an animation of that so you can see the transporters, and we will disclose that in the following video. In the meantime, this is how you can create a model that includes transporter, discrete material handling devices to take product through the stations.